Okay, so for this lesson, we are going to talk about finding the probability of two or more events. And events can happen as mutually exclusive events or not mutually exclusive. So something that is mutually exclusive would be two events that cannot occur at the same time. Okay, so something like that that cannot occur at the same time. That'd be like if you were to draw from a deck of cards a jack and then also draw a queen. There's no way that you can draw a jack that is also a queen. So mutually exclusive events, we're going to say what's the probability of A or of B happening. And the idea here is that we'll find out what the probability of A is, and we're going to add that to the probability of B. Okay? Not mutually exclusive events is two or more events that can occur at the same time. So these that are not mutually exclusive means these events can occur at the same time. And this would be something like the probability of drawing, let's say drawing a jack from a deck of cards and then drawing a red card. So the probability here now of having A or B happen is you would do what's the probability of drawing a jack plus what's the probability of drawing a red card. But the fact that jack cards can also be red, you would subtract out the probability of A, running out of room here, and B happening at the same time. So you would do not mutually exclusive as two separate probabilities that you would add together, and then you'd subtract out the probability that they happened at the same time. We will definitely be doing some problems with these, so don't worry if you're not really sure of the formula. You also then have independent events and dependent events. And independent events are when the first event does not affect the possibility for the second event. And we sometimes call that with replacement. So an outcome can be included more than once. And the example that we talked about in class was if you like to do like the pick 3 lottery. You pick 3 numbers out of whatever is out of random numbers, and each number that can be drawn can be repeated. So you've got 10 digits to choose from for the first number, 10 digits for the second, and 10 for the third. You can have the same number show up 3 different times. If it's a dependent event, it's when the first event does not affect the possibility for the second event. It's like without replacement. And here we talked about the Powerball game. So in Powerball, you've got one thing with a whole bunch of numbers in it. And then as you start pulling out numbers from this jar or whatever the numbers come from, I have no idea. Once you start pulling these numbers out, you don't put them back in. So you can't pick that number again for the second time. Independent events, in dependent events, we talk about the probability of event A followed by event B, so event A and event B. And then what happens here is you find what's the probability of A, and then and really means to multiply, and you're going to multiply that by the outcome for the probability of event B. So I'm not worried about the 2 apples and 2 oranges. You can read that on your own. We talked about the Powerball game and the pick 3, which is replacement and not replacement. So here's how this works. The jar is going to contain 3 red marbles and 5 white marbles. Our marble is chosen from the jar at random, its color is noted, and it's put back into the jar. Then another marble is chosen. What's the probability that both marbles are red? And in this case, we're talking about the probability of a red marble and then a red marble again. So what happens is, in my jar, I've got 3 marbles that are red out of 8 total marbles. And means I'm going to multiply. When I pick that red marble out and I put it back in, I still have 3 red marbles and 8 total marbles. Multiply straight across the top, straight across the bottom, and then the probability of red and red is getting 9/64. What's the probability that the 2 marbles chosen are the same color? Well, if you're the same color, what that means is the probability of getting a red and then a red again, or the probability of getting a white and then a white. Okay, don't forget the words and or. And maybe we'll kind of put that up here. When you see the word and, you're going to think of multiplying. When you see the word or, you're going to think about adding. Well, we know the probability for red and red because we just did that in A. So that's 9/64. Or the probability of white and white. Well, we've got 5 white out of 8 total in our jar. White comes out, white goes back in, and then there's still 5 out of 8. 5 out of 8. So what happens here is we're going to get Red and red, which is 9/64, white and white is 25/64, and then the probability of getting both marbles the same color will be 34 out of 64. A little bit more than half, you'll get both marbles the same color. Let's try another example. Let's take that same jar, right? 3 red, 5 white. You choose a marble and you don't put it back in the bag or in the jar. And then another marble comes out. So what's the probability that both marbles are red? Well, it's the same idea. What's the probability of red coming out and then red coming out again? Well, the first time you're trying to fish for a red, you've got 3 reds out of 8 marbles and needs to multiply. Once that red comes out of the jar, there's 1 left red and there's 1 less marble. So we've got 2 out of 7 for the second shot, which means top, top, bottom, bottom, 6/56s. What's the probability that one's going to be red and one's going to be white? Well, let's see. If we talk about that, I could pick out a red first and then a white, but that's not the only combination. I could also pick out a white first and then it's followed by a red. So both of those are very different draws, but that gives you still a red and a white. So picking out a red first time around is 3/8. We're going to multiply that by, now there's still all 5 white marbles, but there's 1 less marble in the bag when you don't replace the red. Or plus, white marble starting all over is 5 out of 8. White comes out, 1 less marble, but red are still the total that they started out with. So what happens here is you've got 15/56s plus 15/56s, which is 30/56s. Again, a little bit more than half the time you'll get it 1 red and 1 white. Okay, so let's go ahead and do another one. Example 3. Scotty has 2 navy socks and 4 black socks that are loose in a drawer. One dark morning, he pulls 2 socks. What's the probability of getting a matching pair? Well, a matching pair means that he would pick out of the drawer navy and then navy, or he could pick out of the drawer black and then black. Well, navy socks. He's got 2 out of 6. Once a navy comes out, it doesn't go back in, so there's 1 navy left, 5 socks total, or meaning add. Black means you've got 4 out of a 6 chances to get black. Once a black comes out, there's 3 blacks and 1 less sock. So here what ends up happening is you've got 2/30ths plus 12/30ths, which equals 14/30ths. So a little bit less than half the time will he get a matching pair. Here's another one. A card is selected at random from a deck. The card is not replaced, and another card is selected. What's the probability that you're going to get both black cards? So probability of black and black means I've got a 26 out of 52 shot in getting a black card. Once I pull out a black card, there's 1 less black and 1 less total. When you multiply that out, hold on, I forget what you get. Give me 1 second. So this is going to be 26 times 25 is 6. Hold on. So 26 out of 25 is 650, and 52 times 51 is 2652. The next one, what's the probability that both cards are spades? So now we're looking for the probability of spades and spades, which means there are only 13 out of 52 spades. A spade comes out, 12 spades left, 51 cards left. The denominator is still 2652, and 13 times 12 is 156. What's the probability that both cards are aces? So probability of ace and ace. Well, 4 out of 52 aces in the deck. 1 comes out, 3 left, 51 total. 4 times 3 is 12, and the denominator is still 2652. All right, so you should be good with the rest of the homework. Bye.